Hi, today I want to introduce a new term to you. It's called shape function. Shape function is very important for development of a FEA. Let's say you want to develop a new elements that never invented before. The first step you have to do is define the shape function. Okay. So let's start with something simple. Let's develop the shape function of a 1D spring element. Okay. Now let's start with a reference frame. X, Y, okay? And then you have a spring element, just like what we learned in the first chapter. It has two nodes, one node, two nodes. It has a length before you stretch. Any force acting on node 1 is F1. Any movement along node 1 is U1. Same thing for node 2, F2 and U2. Okay. Okay, what we learned previously is either this movement on node 1 or node 2. So you only have movement on, there's only values on U1 and U2, or there's a value on F1 on F2. What about there's some movement along the spring element itself? Okay, so we have to define a function. Let's call it Ux, U as a function of X. And we have to introduce two constants. So now, basically, what it's saying is any movement along the rod, along the spring element, okay, is defined by the location, defined by the x value. Okay, let's put that in a matrix form. Now, the next step, we have to solve for C1 and C2. Okay, when you, okay, when x is 0, we know that, okay, when x is 0, we understand the movement will be U1. Same thing, when x is at the end of it, okay, so when x is L, we know will be U2. Since we love matrix so much, we apply everything in the matrix form. Okay, nothing fancy. I just retrieve the two terms C1 and C2 out of the matrix form, because basically you can see this is that thing looks like a matrix to you. Okay, I just factor out C1 and C2 equal to U1 and U2, that displacement factor. Okay, we do the inverse for that thing. Okay, how to do the inverse for 2 by 2? There's a lot of formulas online, and there's a you can take a look at that, and also you can do a linear row reduction. Anyway, let's do a shortcut here. I assume I know the inverse already. U1, U2. Okay. Okay, let's put everything right here that we developed back to the first equation here. Okay, so u as a function of x equal to c1, c2. Let's do the multiplication. We have two terms. u1 and u2. Okay, congratulations. Now you have the shape function, which is the shape function for one-dimensional elements with two nodes. So why is the shape function so important? You will learn that in the next videos. Thank you for your attention.